Hello, I'm Mark, and welcome back to my Unreal Engine tutorials on how to add suspension systems to our physics simulation component. So, in the last video, we got things set up, but as I was kind of recording it, we were kind of pushing almost an hour, and I still had about maybe another hour and a half's worth of material yet to cover. So I decided to break it up, and so now we're going into part two, which is going to be focusing on integrating all of the work that we did in part one into our physics simulation component, so we can hopefully start seeing a vehicle standing on its own 2 feet using Unreal Engine's suspension system or your suspension system, depending on how you want to configure it. All right, so let's get started. So currently I am in the vehicle simulation component. We've been building this out over a very, very lengthy amount of time. And as we've been doing it, we've been continuing to bolt things on here. So one of the things that we've bolted on during the wheel simulation stuff is our mesh on physics state constraint handle. So this is a little thing that we're going to be listening to, that if this thing fires, we want to react to it. We also, during this simulation, we went and added our mechanic simulation enabled function here. So I think we're going to be adding some additional parameters to this now, so that we can continue to build on this. So I've got mechanics enabled. So let's go ahead and bring in some of the other switches. And I think actually, I'm only going to bring in 2. I've got one more, but we'll get to that when we get to the wheel friction. This is suspension. So what I've got here is I've got suspension enabled, and then I've also got this constraint system enabled. This is something that is going to allow, if we want to use Unreal Engine's physics constraint, we can turn it on, and we can use the Unreal Engine's suspension physics constraint that it actually has built into its API. Otherwise, if we don't want to use it, we can turn it off, and we can go ahead and set things up, and that can be more useful for things like statics, or if you want to kind of set the limitations in the physics asset itself, rather than using their internal setup. All right, so we've got those two. We've got engine simulation, transmission, differential, steering. We added our previously, I think during the when we were working on the blueprints. Actually, I think when we were doing steering, we went ahead and also got the wheels configuration. So we started stubbing this out. So this is where we're going to be defining our wheels. And I think in this one, we'll go ahead and start getting the code to help create that, because we're going to need it. But yeah, this is our wheels configuration. This is where we'll just add all the wheels that we want to use. As far as anything in the control system, we didn't need to worry about that. But then finally, because our wheels are actually going to be classes as part of this simulation, we also added this instanced wheels. And this is actually using a T-object pointer for U-vehicle wheels. Something that I kind of started learning about was whenever you're creating, whenever you're instantiating objects after the runtime, you're probably going to want, you're going to need to use this T-object pointer in order for those instantiated objects to play nice with the Unreal editor and its garbage collector, or the engine's garbage collector. Kind of learned this the hard way after Unreal Engine was crashing a couple of times after I'd made some changes. But yeah, so if you're having some issues and you're wondering why, you run it, it works fine. You stop the editor, make a change, then run it again, and then immediately try and run it again, and suddenly you get an error, and it's pointing to the hash table, garbage collector's hash table. It's probably because you're using a straight pointer instead of this little object pointer. So yeah, just a little tip here to try and harden that. In a game, it's perfectly fine. This is only really if it's just going to be in the editor itself. All right, so those are all the parameters, and we are going to need some additional functions. So let's go ahead and bring those in. So we already have create wheels, and we'll be doing a lot more in there. I'm just going to see if there's anything else I'm missing. Update wheels, set up PT. Yep, we'll need to do some things in there. And let's see, run steering simulation. So we have the steering simulation, we have the mechanical simulation, so we are going to need the suspension simulation. So this is going to be the function we're going to need for that. So apply suspension, delta time. Again, we're going to be taking our rigid body handle. And then we've got the, we don't need that one right now, skeletal mesh. I think we're okay there. But we are going to need a function for our ray casting. And let me just shorten that out. So this is our function. This is where we'll be doing our suspension tracing for each wheel in our system. Oh, and I did forget a parameter, so let's come back up here. So under wheel configuration, to make things a little smoother, we're going to add, I'm going to add this F collision response container. And what this is a container of all of the responses that can come back from that trace, right? And the nice thing about this is that if there are certain things that we want to ignore, we can. So when we get back to our, when we get back to the blueprint, we can go in there and we can say ignore certain things that we want to also. If there's like a custom collision that we've created in the editor for, say, colliding with water, right? Well, we don't want our trace to hit that tile. We actually want our trace to go through it so that our vehicle can go into the water. Now, unless you're wanting to create pontoon wheels which float on top of the water, and then that collision, you'd want to keep it on there. So again, we can customize a little bit using this. So this is going to be the wheel trace collision responses. And this is kind of how we can configure how we want our trace component to interact with those responses. All right, so let me check to see if there's anything else that I've missed. We may be coming back to this over time as I kind of go through the implementation. Let's see, apply suspension forces. We've got the skeletal mesh, which we will be getting into a lot more. I think we have everything, and we don't have any public. No. All right, so we do have some private variables that we're going to need to add in here for the collisions. And for physics constraints. All right, so again, so we're going to have, this is for our trace query parameters. So this is how we're going to set up our trace query parameters for each, so that we can pass these onto each time. But again, this is the collision responses. So we set that up and then we can pass that into there a little bit more. And then we actually have this physics constraint handle. So this is this is the new thing that we're definitely going to be looking at in this video. And that's kind of why I wanted to break this into a part 2. Because the Unreal Engine has a suspension system already baked in when they created their version, their chaos system, right, for their vehicle. And I'm just going to piggyback off that, and so I can kind of show you there. If it's there, we might as well use it. It works really well. So it's, you know, but if you want, but we're going to put a switch in there. So if you don't want to use it, you can turn it off, and if you do want to use it and default to that, you can turn it back on. So. All right, so I think that we've got everything here. So let's go ahead and move over to implementation, and let's get started on getting the code in here. All right, so again, I'm going to be bouncing around a little bit since there may be some things that I may have left out. I'm trying to make this as complete as possible, so I'll put that up front. All right, so starting off with begin play. there's really nothing new here. I think we're good. We've got the wheel create setups, and we've got the skeletal mesh, so we're good there. So let's move down to create wheel setups. So here we've done a lot of work since we created this function, and we put the engine simulation initializer here. So I think we're ready to start building this out a little bit more. So what I'm going to do is, so let's go ahead. I'm actually going to finish this off because there's really not much more that we really need when it comes to the between the wheels and the suspension stuff. So let's just finish off our create wheel setup. So out of the gate, I'm going to need this mass load distribution, and this mass, since we're creating wheels and the wheels are going to be carrying the load of our vehicle, we need to make sure that we evenly distribute that load amongst the wheels of the vehicle. So what I'm going to do is I'm going to create this little variable, and in order to get the mass of the vehicle, I would recommend get mesh off the mesh, and this is coming off the umesh component, and there's a function called get mass. There's another way you could do it off the handle, which is the mass off the handle, but I found that it's not necessarily accurate when it comes to skeletals. It's accurate, and it's only really accurate when it's comes to statics if the static body is the primary. So that's why I'm going to use this umesh get mesh instead. And we're going to then take this and we're going to go ahead and divide that by the number of wheels. So each wheel needs to be able to carry a portion of the total load of the vehicle, right? So because that's what's in contact with the ground. So this is going to be our mass. This is our mass load distribution. And then next up, we are going to run an iterator. I'm just going to go ahead and just bring this over in pieces so we can continue to go through this. So this is our physics wheel setup. So this is the struct, which is going to be carrying all of the wheel configuration classes that we're going to be using for the various wheels. So what we're going to do is we're going to iterate through here, and then we're going to create an actual instantiated object, which is going to be where our wheel code is going to be. And so as we go through, we're going to first, just going to copy this over. And let me just clean this up a little bit and that up a little bit. So as you can see here, we've got our wheel vehicle here. So what we're going to do is we're creating a new object here of wheel vehicle. This is the component and this is the wheel class. And so this is what we're setting up in that structure. And we'll see this when we get back to the blueprints as we go ahead and create those wheels. So, and as you can see here, I've got an index of 0, and so what I'm doing is I want to synchronize because we're going to have 2 arrays for these wheels. We're going to have the instantiated objects as well as the structs. The struct is really just the setup information, where the instantiated object is really going to be where the simulations are actually going to be executed and ran. Right, so I want to be able to sync those arrays without having to do kind of multiple loops to try and find things. So what we're going to do here is I'm going to create an index, and I'm going to add that index to the wheel index here in the struct, as well as and eventually add it into the wheel here instance as well. So we can kind of map those two together. Also, because we're working with an object, we need to make sure that this object is good. So only if this pointer is valid do we want to actually continue our work. And we'll get to that a little bit later. All right. so next up is going to be our location. So if we're dealing with a skeletal, or if we're using a socket to give us a location for our wheel, or if we're not using that and we're just going to use just the generic location, we can just go through here. So what we have is, this is the wheel location, bone socket name, and we're checking to make sure it's not none. So if we have something in here, we're going to go ahead and set our rotation point to the socket location information that we're pulling off here. I'm just going to go ahead and just use this for now. You may want to add a little bit of a check in there to just go and get the default and set that to the rotation point if that's what you're looking for, if you're using statics. But right now I'm just doing everything in the context of skeletal, since that's what we have to work with. So what we're doing here again, like I said, we're going to be bouncing around a little bit. I'm just going to go ahead and add the wheel profile in it, since we're going to need that anyway. But what we have here, so the rotation point here is the rotation point that the wheel is going to be rotating around, and we're going to need that rotation point because we want that same rotation point for the resting point for the initial resting point for our suspension. All right, so wheel profile in it. Let's go in there and just fix that real quick. And that is, let's see. All right, so under wheel H, interesting. Oh, wheel profile in it. So let's go to vehicle. Where is that? Wheel simulation setup. So I'm just going to go ahead and minimize our suspension structure. We're going to come up to our wheel setup, and we're just going to add a new function in here, which is the initializer, real quick. All right, so I'm going to take a look. We'll be getting more into the wheel setup when we get to wheel friction. So I'm just going to put some things in here right now. Just to kind of satisfy it. So this is just the init function, and we're just going to go ahead and, just so everything compiles, I'll just go ahead and add that over here. Just going to minimize all of this real quick. And let's go to this. Let's see, this is above or below? It's above, so just gonna put that there. We'll fill this in when we get to wheel friction. But you know, we'll just leave this here for now. But we'll get to this when we get to wheel friction. Actually, we may need to actually do some work here, because we do need that wheel radius for our suspension setup. So yeah, let's go ahead and just do that real quick. So I'm going to add a new variable called dynamic wheel radius, and we'll get more into this when we get to wheel frictions, but I'm just going to go ahead and add this as an additional parameter. And I'll just put this up here. So we'll probably add we'll be adding a couple more things in there, but that's more specific to friction, so I'm going to hold off on that. But for now, we just need to make sure we've got the wheel radius, because this is something that we're definitely going to need for the suspension, so we know exactly where the length of that ray cast when we're going to draw it from the resting point of the suspension. All right, so that should satisfy this. There it is. Okay, good. So let's get back to the implementation. So you can see engine enable is set to false, and we're setting this to false because so what we do is what we're doing is we're actually telling which wheel has power and which wheel doesn't. I'm setting this to false here just to make sure it's set to false, because we're going to be making that decision using the differential code that we wrote earlier on when we did the transmission. So I'm just going to bring all of that over. And that's done here. So what we're going to do within the wheel profile, and this again, we'll be creating blueprints off this. You can set the axle type, and the axle type can either be front wheel, rear wheel, or it can be freewheel, right? If it's set to either a front or a rear, then we're going to check the differential code to determine if that front wheel is going to have power enabled or not. So if the differential, if this is a axle type of front wheel, right, on this wheel, and our differential, and we check the differential to say the power is either going to be all-wheel drive or front-wheel drive, then we'll turn the power enable switch on. And again, we'll do the same thing for rear wheel. We'll check to see if it's all-wheel drive or, oops, actually, this is not right. Should be rear wheel. So this is front wheel drive. So if this is all wheel drive and this is rear wheel drive, little bug there, then we'll put the power on the rear wheel. Otherwise, if it's set to freewheel, we'll just keep it in the off configuration. It's just a wheel that's just going to roll, and it's not going to have any power to it. All right, so that should do it for our power differential. So when we get to, well, again, we'll see this in action again when we get to wheel friction. But we're setting it up now since we already have all the other pieces set up. We can go ahead and do that. And now we're coming into the suspension part. So now that we've set up the wheel, we're going to start setting up our suspension profile. So our suspension profile is sitting on our wheel. It's right here. And so we need to go ahead and start setting up. So we're going to run the initializer that we've set up. And then from here, we're going to set the local resting position to the rotation point of the wheel. So this is the rotation point. We've got the set here. So we're going to get it here. We're also going to need our damping, and again, we're going to need to create ourselves a set of helper utility functions to compute that damping. So what I'm going to do is I'm going to go over to our physics simulation utility, and we're going to go ahead and create those utility functions. All right, so I'm just going to put it in we already have a utility function file. This is our physics simulation utility. So but rather than just add these functions into this, I'm actually going to create a separate static class, which is going to be just for our suspension functions. So again, make sure the API, this is our physics suspension utility, and it's going to have three functions. It's going to have compute natural frequency, compute the critical damp, and then we'll also have compute the damp. And so let's go ahead, just fix these real quick. This is going to go in the right place. All right, so let's go ahead and fill those out. So for the frequency, what we're going to do here is we're going to take the square root of the spring rate divided by the sprung mass. So we'll be passing in spring rate, sprung mass, and we'll then get the square root, and that's going to be what we're going to be referring to as the compute natural frequency. If we want to do the compute critical damp, so we have two options here. We can either do compute critical damp or we can do compute damp. We're actually going to be using compute damp since we're going to have this damping ratio. So what we're going to do here is we're going to calculate the natural frequency here. So we're just going to use this function, right? Get the natural frequency, and then for our critical damp, we're going to say 2 times sprung mass times the natural frequency, and that's kind of how we're computing that. If we're going to be using, now we're going to be using compute damp instead, but we've got two of these since we have a ratio. So again, the only difference here is that we're going to take our ratio, we're going to make sure it's clamped between 0 and 1. So this is a ratio between 0 and 1. And then what we're going to do is we're going to then, again, compute the natural frequency. Again, we have that function right up here. And then from there, what we're going to do is we're going to say, we're going to multiply the damping ratio that's coming in. And this is the damping ratio per tire or per wheel, right? And that's going to be set up. Actually, this is a damping ratio per suspension on the wheel, right? So that's the suspension on the wheel. That's going to come in here. We're going to multiply that by 2, and then we're going to multiply that by the sprung mass and then the natural frequency. So if I save all that, and I come back to our vehicle simulation components. All right, and there it is. So let's just roll this over a bit so we can see what's going on. So here's our damping. This is the actual damping that we want to add to our suspension. This is going to help us, as it's kind of going up and down, we eventually want that spring to get to 0. So it's, not rocking backwards and forwards while it's standing still. So we have computing damp, and we have the suspension profile spring rate. So that is the spring rate there. Now this is where we're going to be using the mass load distribution, right? Again, each wheel is going to carry a portion of the weight of the vehicle, and technically this mass load would change dynamically as the vehicle's rolling. But for now, we're just going to keep it simple, and we're just going to divide by the number of wheels. But in theory, and I think we do change this a little bit on the fly. This could change based on the number of wheels that are actually in contact with the road. But for now, we're just computing a damping force, so we're just gonna use it from the resting position, assuming all the wheels will be on the ground. And then from here we have the suspension profile, which is a damping ratio. So this is something that we can set. And we'll get to that when we get to the blueprint. So we'll be able to set this as the ratio we want. And then that's going to create our damp for that wheel. All right, so moving on from damping forces. We're going to go ahead and set those as part of the simulation. So we have the rebound damping, that's right here. We have the compression damping, which is the same. And then we have set resting forces. Again, this is mass load distribution times gravity going in the opposite direction. That's the resting force. So that's considered the force that's going to be at rest. It's going to be keeping the vehicle from sinking, down into the suspension. And then finally, once we've got the wheels set up, we're just going to go ahead and go into our instance array and then just add it in there, right? And then we'll just increment this index, just using a ++ incrementer. So this is set here for the struct. This is then passed into the set wheel index, and then we're just going to add it in here. And because this is, in order, we should, this index and this array should match up. All right, and then finally, Once all that is done, we're going to go ahead and set the wheel instance by running the initializer. So this is something we did in the last video. And again, this is something that we want to make sure that because we're tracking the state of all of these, again, we just want to make sure that we instantiate all of these arrays to the right number of wheels that are going to be rolling. So that's what we're doing there. All right, so that should do it for wheel creation. So we've got everything here. We've set up the wheels. We've set up the suspension on the wheels. We've determined which wheels are going to have power and which wheels don't, based on the differential and the axle type on the wheel and the differential that's being set on the transmission. All right, so next up in the list here, let's go to update wheel state GT. All right, so yep, we're gonna need this. All right, so in here, so before what we did was we've got the throttle input and we've got the shift up, shift down, the transmission type if we wanted to update that, and then we've got the steering input, right? So this is all the inputs that are going to be set on the inputs that are then going to be passed into the physics state or to the physics thread to be implemented in the simulation. So what I'm going to do here is we need to update a couple other things. So I'm just going to put this above the engine throttle inputs. And all of this is required for our suspension tracing. We've got vehicle is in air. Let's go ahead and add that real quick. So we missed a parameter, which is the is in air, and this is useful suspension. So if the vehicle is in air, we'll be able to flag that. And this is usually if all however many wheels are on your vehicle are not touching the ground. You can determine if it's in the air versus number of wheels on the ground. So again, we're tracking this in the wheel state. But first, let's go over what we're doing up here. So we have these trace query parameters. We added them down here. So I scroll all the way down here. So this is for our suspension tracing. And so what we've got here, so we're just going to create a generic query parameter. For what we're doing, we actually want the material. This is the physics material. And we're going to set this to true. And what this allows us to do is it allows us to, on a physics material, right, you can set a friction coefficient on that material. So we can actually use this. And this is going to be more relevant when we get to wheel friction, where we want to see what is the friction of the material coming back, and then that friction is what we're going to then start to we're going to add that into our friction simulation to help us generate thrust off the wheels. But for now, so we're just going to put that there. We're just going to set that to true because we want that coefficient. And then another trace query parameter is ignore the actors. So what we want to do is we want to make sure that when these line traces go down, we want to make sure that we're just ignoring ourself. We don't want to include that as in any of the hits. By default, I'm going to set this trace complexity to true, but we can actually override that a little bit later. And then as far as the simulation state of the vehicle, again, we've got the number of wheels on ground, and we're setting the vehicle to in the air as false. And we'll go ahead and run some code just to go and check to make sure that we are either in the air or on the ground. So let's go ahead and just get this variable done first, and then we'll come back and do the wheel check. So let's just do that. All right, so I'm just going to pop over open vehicle movement traits, and I'm just going to add this underneath here. So there's a new property, is vehicle in air, and if we want to expose this to the blueprint, we can go ahead and do that as well. So if you wanted to then pull this information into the blueprint to check to see if the vehicle's in there, if you needed to do something, you can see it there. So edit anywhere and blueprint read write. Alright, so let's go back. Alright, so that should fix that. Red squiggly. And I'm going to bring in the code for our wheels check. So again, this is the wheel state GT. This is going to be called on the game thread on every tick as we're kind of updating this information. So this is kind of where we're going to be going in and checking the updating. We want to update the wheel state on the GT based on the information of the wheels that we have right now. So again, this is the wheel instance of wheels. So we're just going to iterate through that loop. Here's our simulation state for the wheel state, and then we're just going to run the update state GT that we did in the last video. And we're just going to be passing in the wheel index, the resting point of the suspension, and the body instance. Since this is on the game thread, we're going to be passing that in. And then so that's going to update the all the information on the wheel. So then the next thing we're going to do is we're going to check to see if the wheel is in contact, right? So this is the wheel profile. And this is in contact. So this is going to be part of the wheel simulation, so that we're going to check to see if the wheel is in contact with the ground, and that's going to be based again off the trace that we're going to do for the suspension. So suspension is going to do two things. It's going to determine where that wheel position is going to be, but it's also going to check to see if that wheel is actually still in contact with the ground. And we'll be updating the wheel profile with that in contact. If it is in contact, then we'll just increment the number of wheels. If it's not in contact, then we'll say vehicle is, and we'll just set this to true. And we're doing this per wheel. So if all the wheels are in contact, this stays false. If one of the wheels is in contact, right, then, but or all of the wheels but one are in contact, this flag will get true. So it is possible to have well, it should never really be possible to have this in air if all the wheels are in contact or on the ground or not. So, but we do, well, technically the vehicle is technically in the air if one of the wheels is off. So we can set that flag. But that's kind of how we're going to do that here. Alright, so that's kind of how we're calculating that and determining whether the vehicle's in the air or not. Or is starting to get into the air based on whether all the wheels are on the ground or not. Alright, so is there anything else that I need? I'm looking at transmission. Nope. We'll come back here when we do wheels, when we do the wheel simulation. But I think we've got everything we need for suspension set up. All right, so let's see. Next up is going to be update wheel state PT. Do we have that? Yep. Just going to go and collapse these. So this is our wheel state in the physics thread, and so we've got some additional things that we want to do here in the physics thread, just like we're doing on the other side, on the game thread. So first thing, I've got the simulation state. Again, I'm going to set this to is in air. So I'm going to set this to true, which is the opposite of the game state where we set it to false. And then what we're going to do is we're going to set the number of wheels on ground. So again, we're checking in both states, and we're trying to we want to keep the wheel state as up to date as possible. And let me just bring all this in. Get effective effective radius. All right, so we've got 2 new functions we need to add to the wheels in order for us to get this information and work with this. So let's get effective radius, and we need to add the function set on ground. So we'll go ahead and add those in, but we'll just quickly go over this. So again, this is the wheel. Again, the wheel instance. As long as this is valid, it should be. We're going to take the wheel simulation. This is the profile. This is the suspension profile. So we're just creating a W and an S. For the wheel state, we just need to update again, we're going to update the wheel state index resting location. This time, because we're on the physics thread, we're going to take the handle instead. And then this is where we're going to be updating the world raycast, the update world raycast location. So this is the location of the where we want to start our trace based on where that wheel is. So this is where we need the transform, which is the transform for the vehicle. So, and this is going to be the effective radius. So we need to get the effective radius of the wheel, and we also need the wheel suspension trace, which is going to be set per wheel. All right, so this is our trace information, and this is actually an output parameter, which we'll then use for our tracing. All right, so let's go ahead and get the set up the effective radius and set on ground, and also do the set on ground as well. All right, so let's go to set up simulation. So again, wheel simulation. So this is the wheel simulation, which this is still a work in progress. So we need to add a couple more functions for this thing to so again, the wheel and the suspension need to work together, so we need to add some additional information so they can trade information. So we need to add the get effective wheel radius and I'm just going to go ahead and put that here. So this is the effective, and so this is the dynamic wheel radius that we created, and this dynamic wheel radius is what we're setting to the wheel radius right in the initializer. So we're going to say, okay, take this and put this in here and add this to the dynamic wheel radius for us. And then after that, let's see, we need the other function, which is our set, is our setter for the on ground. And I'm just going to go ahead and I'm just going to put that there since it's using the same variable as in contact. So again, we need to set this to let the wheel know that it's in contact, so that, because what we'll do is we'll do the suspension simulation first, and then off the suspension simulation we'll then run the wheel simulation. So the suspension is going to tell the wheel whether it's in contact or not, and if the wheel's in contact, then it will, as it's running its simulation, it will do whatever it needs to do, right? And then it's then going to report that back to the GT, to the game thread, as the game thread's picking it up to say, hey, I'm in contact. So the game thread would update its information as well as the physics thread on the next tick before it goes and runs the simulation again. All right, let's see, let's go back. So that sets that. Okay, so we've got the world raycast update, so we want to update the position of the wheel within the bounds of the spring. Calculate suspension tracing. So this is our new function that we'll be using to calculate the suspension trace, and then we have the set on ground, and then we have the in context. So I think the next one we should do is go to the calculate suspension tracing, so that we can see how we are going to calculate the height of the spring. Alright, so I put this below the skeletal, so I'm just going to go and bring it all over and bring this in. So this is our calculate suspension tracing function, and just need to fix that real quick. Alright, so this is calculating the so on each wheel, right, we need to know if it, is it on the ground, and based on the spring simulation, how far, how far up or down it needs to be calibrated to the ground to simulate that suspension. So here again, we're taking in a pointer, so I always like to make sure that the wheel is valid. If this is valid, then we'll run the suspension. So this is where we're going to use World Dynamic on this for the spring collision. We have the response parameters. So these, again, this is our collision responses, and that's over here. That's being passed in the function, as well as the collision parameters, and these are the parameters per wheel. These are the responses for the solution. We are going to need a hit result. So what we're going to do is we're going to go into the wheel state and get a not a copy, but a reference to the hit result. So what we've done is, as part of the initialization, we actually pre-created these hit results and set them up. And so what we want to do is, for each wheel, we want to get the hit result that we have here and bring that over in and get a reference to it. Because we're going to then be passing that into either the sweep or the line trace here. Right. We want to calculate the length of the spring. So to do that, we've got our start trace and end trace, and again, this is set in the wheel state suspension tracing. So that's where that's located. And again, we're keeping the state of this. So start trace, end trace. We want to know if we're going to be using a complex or a simple sweep. And then from there, we're going to go ahead and set the trace. So this is our trace vector. This is really only needed if we're going to be doing a sphere trace. So we want to have the start minus the end. That's the trace vector, and then the normal, which is to get the safe normal on that. Then this is where we'll check to see if we're going to do a shape sweep or a sweep shape, and this is going to be based on either sphere or raycast. So if it's a sphere cast, we'll take the wheel radius, right, and then we'll get the vector up axis, which is coming off the safe normal, and then we'll then run the sweep single channel, taking in the hit result, the start plus the up axis times the wheel radius. So it's really going to be up axis times the wheel radius, multiply, and then add the start. The end trace is just the end, and then identity collision channel, which is being set up here, which is World Dynamic. And then what we're going to do is we're going to make a sphere, which is the collision shape. This is how you do it by sweep by single channel. Wheel radius, that's the shape, and then the collision parameter and the response parameters. If you're just doing a simple raycast, we don't need to do all of that. We just care about this, the hit results. And again, this is a pointer. These are these are references. So this is the start channel, end channel, or start trace, end trace, collision channel again, parameters, response. And then I added a little debugging so I can see the lines. So if you wanted to draw out the lines for your raycast, you could do that. So I'm just using a draw debug, get world, start, end, and this is just going to draw a line based on these two parameters, these two vectors. That way, if you wanted to see where if your suspension's not working, you can turn on debugging. This would then show the lines. That can be useful, especially when dealing with meshes where you may have a root bone where you may need to add some offset to it. All right. So that should be calculate the suspension tracing, and that is getting done right here as part of the update PT. So we'll update that, update the suspension tracing, and then based on that, we'll then determine whether we're on the ground or not. So this is the blocking hit. If there's a blocking hit, it'll tell us if we're on ground or not. If there's no blocking hit on that wheel, then we're in the air, and then we'll check to see if the wheel is now set to in contact or not, and that's where we'll then do this information here. And then this is where we'll set the all wheels on ground based on this and the number of wheels in the configuration. All right. Next, I think we will do the skeletal mesh setup. So this is something that needs to get done. This is getting done on begin play. So what we'll do is we create the wheels here on begin play. So, and then after that, we then need to do the skeletal mesh setup. And as you can see, I have a note here. And the reason why we want to do this is that there's some things that we need to set up first on the mesh. We need all the data so that we can successfully go and set up this mesh. So we initially set this up for animation, but I'm now going to set this also up so that we can take advantage of Unreal Engine suspension constraint. So we're going to go ahead and show you how you can set that up here. All right, so this is going to be a rather lengthy function because there's a lot going on here. So I'll try and bring it in pieces so we can kind of see what's going on. So let me just bring in the first. I'm going to just bring in everything up to the main loop first. So we've got to run some checks. So again, so this is if you want to use the suspensions. If you want to use this system, you can turn it on or off. There's our switch. Next, we need to get the physics asset. So this is on a skeletal mesh. So we're going to get into the mesh, get the physics asset, and again, this is all being done in the context of this massive if statement up here, which is the skeletal mesh. So that's where this variable is being set for skeletals. So get this, get the mesh, but we'll get the physics asset, and then once we get the physics asset, we can then start iterating through the wheels. So that we can do our thing. So let me go and bring the next piece. So what I'm going to do here is I'm going to take a look at our instance wheels. And so this is the wheel, this is the index. We're going to do an is valid on the instance wheel. So we want to, again, we need to make sure that our indexes that we're rotating through are going to be in sync. If they're out of sync, then we don't want to do this. Otherwise, we'll get a pointer validation error and things will blow up. So again, we're just going to do a quick check there to make sure everything's good. And then after that, we're going to run another if statement to check to see if this wheel has a bone socket location name. And again, that's on our setup. So again, here's our wheel, here's our location. So we have this nice little struct which houses that information. If this is not none, as like there's a name there, there's a bone or a socket that we can use. We'll go ahead and run that. All right, so after we've done all of those checks, we're going to go ahead and create our bone setup index, and this is where we're going to need to use the physics assets. So as you can see here, I've got a red squiggly, which means we need an include statement. So let's go ahead and satisfy that. So up here, this is where we keep all of our includes. So we're going to need a couple of other things here, and this will probably be a good place to kind of bring in all the other things that we need. So game for brush. All right, so for our physics assets, I'm just going to go ahead and just put them all together. We're going to have a lot of, there's going to be a lot of includes in here. So we're going to need physics material. So this is when we do the collision to check to see what materials under our wheel. Physics asset, that's the asset that we just referenced. And then we have this physics engine skeletal body setup, which is also what we need. And again, these are all under, these last two are under physics engine. And then I'm also going to bring in some other includes because we're going to need them for the constraint. And to do that, I'm going to reference the Chaos engine interface, the Chaos suspension configuration. We have the physics proxy, suspension proxy, as well as the PBD rigid solver. This is what's going to be used if you decide you want to use the suspension constraint system. So what we're going to be doing here is we're going to be removing the constraints that were put in the asset, and we're going to replace them, do a wholesale replace of those constraints on those wheels with this new constraint system. So let's go ahead and do that. So that's kind of what we're doing here. So what we're saying is, here's a physics asset, find this, find this on the physics, in the physics asset. So when we set up the assets, or if you go into the asset, let's see if we can find that real quick and kind of show you so we can kind of get an idea of what's going to happen here. All right, so if I bring this over real quick, so what we have here is we have these constraints which are part of the physics asset, right? And so what we do is we brought all of these in, and as you can see here, we set the default here on the asset. This should actually be set to simulated, right? And what's going to happen is, but I'm going to leave these as default because I don't necessarily need these to change. Because what's going to happen is that what we're going to do is we're going to actually take all of these constraints and actually remove them programmatically and replace them with a Unreal Engine's Chaos suspension constraint instead. And so that's what we're going to do. And I think that and it's a nice little way of being able to remove things or add things programmatically. So that's what we're going to do. So these are the constraints that we're going to iterate through, and as you can see, each one of these constraints is by the bone joint. So we're looking for the bone joint. So when we find it, we're just going to remove it, and then we'll turn around and then replace it with the new constraint that we want to use. So let's just move this off screen real quick. All right, so in order to remove that constraint, we are going to do this. So again, so we're going to take a look at the body setup IDX, if it's greater than or equal to 0, and IDX is less than the mesh number, right? What we're going to then go is we're going to bring in the body instance, which is the bodies. Do this body instance wheel, set response to all channels. So what we're going to do here is we're going to just pretty much tell it to ignore. So if there's a channel in there which is saying it's going to collide, set to collide, we're just going to reset it to ignore. And then we're just going to iterate through the physics asset by the IDX number and set the instance simulate physics to false. Right, since we don't need to worry about it simulating physics anymore, because we're just going to go ahead and chop it all off. So again, here's the wheel constraints, and so we're going to go through and we're going to just remove every single constraint on that wheel at that joint. And this is kind of how you do that. Here's the constraint instance, constants, mesh constraint, wheel constraint at this, so there's the constraint ID, wheel constraints in the list. So what's happening here is this is finding all those constraints and putting it into this array of indexes, and then we just go ahead and remove those constraints, and then So here we're finding the constraint, and then here we're just going to execute this terminate constraint on there. And that's how you remove constraints from a physics asset on the fly at runtime. All right, so once that's done, we're going to go ahead and replace it with the Unreal Engine's suspension constraint if we want to use their constraint. And that is done through this process. And I've got a couple more functions I need to add there. But so again, we're going to go ahead and get the body instance, make sure it's valid. And then because we're setting this up at runtime, we need to block. And here we're just deleting these things, so we don't need to worry about putting a block on this. But what we need to do is we're writing new constraints to the simulation at runtime. So to do that, we need to use the execute write, which will put a lock around the handle. And once the lock is around the handle, we can then go ahead and create our new constraints. So here, once we have the lock, we'll get the instance of the model. This is the location of the resting position of our vehicle, right? And then we're going to get the physics constraint handle. So here, off the physics interface, there's a method called create suspension. So again, this is actually sitting in the physics interface to create the suspension. So we can go ahead and use that. There's the chassis, which is the This is the actor handle. That's the This is the physics handle. So we're going to pass the chassis in, and then this is the wheel location, right? So that's going to create the constraint handle for our suspension for that wheel. And then from there, as you can see here, we have the constraint handle is valid. Make sure it's valid, and we have the constraint valid, or actually not the constraint, the instance wheel here. And we're going to make sure that we have a valid wheel. So we need to make sure this is valid and that is valid at that location. If everything lines up as it should, then we're going to go in. We're going to go and get that wheel instance out of the array by pointer. So we're going to get a pointer to it, and then from there we have our constraint handle, and we're going to add. So this is a list of constraint handles, and we added that down here. So we're actually having a running list of new constraints. So these are the handles to those constraints right here, so that we know that they're being created. And then this constraint has these methods on it, so that we can set them up. And this is all we need to do if we want to use this system. So we have the set hard stop stiffness. Again, this is coming off the suspension profile. Set the spring stiffness. Now we're going to need to create some new functions, and I'm going to create these under the utility. This is our meters to centimeters, meters to centimeters. So some people kind of reached out sometimes saying when they're working with suspension systems that they're using very, very large numbers, and it kind of feels weird. In some ways it does, but in some ways it doesn't. Usually if you feel like you've got a large number, it's usually scaling. Unreal Engine works in centimeters. So here what we're going to take is I have a small number. We're going to multiply that to convert it from meters to centimeters, so that Unreal Engine can then process that. So sometimes you might just want to then put a conversion in there to take that large number and make it look a little bit more manageable. So let's go ahead and do that to finish this up. And then we'll just come back, and just double check our work here. So let's go back to our utilities, and I'm just going to go to utilities here and add the functions here. All right, so what I'm going to do, I'm just going to add them down here. So this is our physics simulation utility, and I'm going to add two functions. So this is our meters to centimeters scaling, which is what we want. But I always, if I'm going to do this, I always like to put the reverse just in case we need to bring it back for any reason. So There it is. It's in our utilities for our simulation. Just going to save that. Now if we go back to our component here, that should fix itself. Should fix itself. Physics simulation utility meters to centimeters. Oh, brought the wrong one over. Let's go back to this. Yeah, that would explain it. That's the one we want. Already had the scaling. So this is centimeters to meters. This is meters to centimeters. This is just the conversion that you can use. So that should fix it. There it is. All right, so again, spring stiffness. All right, it's just taking the spring rate. Bring this over. We're just taking the spring rate on this instanced wheel, and we're just multiplying it by 0.25. So we're going to take a quarter of that, and then we're going to convert that from meters to centimeters. And then preloading, here it is, which is, we're just going to take the preloading as is. Dampening, this is our damp ratio multiplied by 5. Set min length, right? And this one, we want to make sure that we want to go in the, we want to change the direction. So this is the suspension max rise. We're just going to, for this, we need to again put a -1 in there. Max length is the maximum drop. So min length is going to be the rise, max length is the drop, and then the axis, this is the direction. And again, this is going in one direction, so we're just going to put a -1 in there to convert it and spin it around. So it satisfies the constraint here. All right. All right, so now that we've got the constraint system set up, if we want to use this constraint system, again, it's on the use system, use constraint suspension system if we want to use it. Now I think we're ready to go ahead and apply the suspension forces to our vehicle. So I'm just going to come back over to our vehicle component. As you can see here, we've got a new we have this function. Let's go ahead and first I'm just going to go ahead and put the potential fixes so it adds it. And then what I'm also going to do is I'm going to come back up to our update simulation function, and we're going to go ahead and just add this in there. And I'm just going to put that right there in between mechanical and steering for now. So again, and just as a reminder, so the way that the system works is we have this simulated physics tick. So this is on the physics thread, and what's happening is that we're going to be updating the physics, our PT, which is the update state of the vehicle. So this updates the location, velocity, and all of that information on the vehicle. Then we also have the wheel update, so we want to update each wheel on the vehicle. And then from there, we then apply our inputs. So this would be our throttles. When we get to wheels, we'll also add brakes, as well as the gear up, gear down on the transmission and steering. So that's where that gets applied. So once all that information has been updated and ready to go, we're now ready to run the simulation on the latest instance of all the data that we've grabbed for the vehicle. So that's going to be done in here, and as you can see here, we're running through all of these simulations where they're applicable. And so now what we do is we have wheels, we have suspension. Let's go ahead and do this. So first thing I'm going to do is I'm going to double check to see how many wheels are in contact with the pavement or the ground. So here we are. So I'm just going to run a quick little loop on each wheel to see if it's in contact. If it's on contact, we'll update the contact number. And then after that, I'm going to bring in some variables. Actually, we are going to run this loop again. Let me just set this up real quick. All right, so I'm going to run this loop again. So what I did, this is like a pre-check. Again, just doing a quick pre-check to see how many wheels are still in contact with the ground. This could be done here. I think we could also do it up here as well and just carry that information over. But this is kind of how I've got things set up right now. So once we've got that, we're going to iterate through each wheel and we're going to start calculating the suspension constraint, or the suspension values that we need to move our vehicle's wheels up or down based on our spring simulation. So to do that, I'm just going to bring these three variables in. So first off, we're going to need the hit results. So this is the results coming from our calculate suspension tracing. So again, this is done on the wheel physics tick. So that's what all of this does. It goes and gets us that trace information. So this is the hit result. And then what we need is the new desired length. So this is just the default right now, and we will get that information when we're ready to determine whether we're in contact or not. So right now we're just going to give it a desired length, and we're just going to make it 1. Just to make sure that there's a value there. And then finally we need the suspension move position, and this is based on the suspension profile get max length. And this is just all multiplied by -1. So again, making sure that we get things in the going in the right direction. All right, so here we're going to make our first decision on whether we want to use the Unreal Engine, whether we want to use Unreal Engine's constraint system. So again, if we turn this on, what we're going to do is we're going to allow Unreal Engine's constraint system to take that tracing information that we've created and determine where it wants, on how it wants to set the vehicle in relationship to the ground for each wheel. So to do that, I'm just going to go ahead and grab that. So again, if we don't want to use it, we can turn it off. And so when we turn it off, we won't do any changes to the asset. And by turning it off, we won't. If we're using a skeletal with physics asset, if we turn it on, it'll remove all the old constraints and replace it with a new constraint. But here, this is where we're going to be using the new, the constraint system. So again, going through each wheel, checking the index. So making sure that we have the right, and this again, because we're using this constraint handle list now that we've created, we want to make sure that each wheel is, that we've got the right wheel for the right handle. So then on the constraint handle, so that's what this if statement's doing here. So on the handle, we have the constraint handle. Again, we're going to go into that list of constraints that we created earlier on the skeletal, and we're going to, by the wheel index, we're going to pull that constraint back. We will check to make sure that this is a valid constraint, so there is an is valid. If this handle is not valid, we are going to bypass it. Otherwise, if we don't, if it is invalid, we could break the code and break the engine. So we're just going to go ahead and make sure it is valid, or is still valid. Then from there, we've got the suspension constraint. So what we're going to do is we're going to take the constraint handle, right? So this is our constraint handle, and in the handle there is a reference to the constraint, and we're going to static cast it. So we're using it. So in C++ we have this thing called static cast. We're not, instead of using the cast, because this constraint, right, is an object that is part of the engine, but it's not being managed by Unreal Engine's garbage collector. So this is a constraint that's been built. We're just going to pull it through the static cast using this keyword here. This is the C++ keyword for static cast. So we take this, cast it to the constraint, which is the suspension constraint, which is our chaos suspension constraint. And then from the chaos suspension constraint, we can then use the suspension constraint physics proxy, which again is part of the constraint. So we get the proxy there, and so now we're working within the chaos physics system now. So we have the target position. So we're going to create this structure called target position. And then we're going to go into the wheel suspension shape. So if we're using a sphere cast, we're going to take the hit location on the sphere cast, and that's going to be the target position. If we're using raycast instead of sphere cast, then all we're going to do is say, okay, take the impact point of the raycast, and then we're just going to take the effective radius, multiply that by the up axis of the vehicle. So we want to make sure that that's in the right direction, and then we want the impact point instead of the location. So, and this is for, so this is what we're doing on raycast. This is what we're going to be doing on spherecast. After that, we've now got the target position of where where the ground is, right? And so then from there, we're going to then call this physics solver. So this is kind of why we needed to bring all of these other includes in. So this is the engine interface, this is the suspension constraint, this is the constraint proxy, and then this is the solver that we need. So if you're creating custom constraints, then we need the, this is the constraint solver. And the solver is actually what's going to then run the calculation to determine where we actually need to, whether the vehicle is going to be going, whether it's going to be going down or up, or how it's going to act within the suspension system. So we're going to get the solver. So under the proxy has the solver. So we're going to go ahead and get that solver right, and then once we have the solver, we're going to say set suspension target, and so that's going to be the constraint, that's the target position, this is the impact normal, and we have the and whether the wheel is in contact with the ground or not. So we've already determined whether it is in contact, so the solver just needs to know that so that it can go ahead and do what it needs to do. So that's kind of where it is. So as you can see, if the wheel's not in contact, then the solver then is going to disable it. Otherwise, we're going to enable the solver, and it's the solver which is going to keep the vehicle, and keep the suspension and the wheels of the vehicle where it needs to be on each wheel. All right, so that's if we're using the physics constraint system. So I'm just going to go ahead and take this if statement, and let's just tighten this up a little bit. So that's if we're using the physics constraint system. If we don't want to use a physics constraint system, we still need to do some information. We still need to create some force data. It's just whether we want to apply it or not. So I'm just going to go ahead and grab this. And we're just going to bring this in here. And we're going to need some additional functions on the wheel profile. So we'll go ahead and add this. We don't need true massive object. This is actually going to be get mesh. Get mass. All right, that should solve itself when we get to here. All right, so what we're going to do here, I'll just walk through it. So if we're not using the suspension system, then what we're going to do, well, we still need to do this information anyway, because we still need to pass some of this information into the wheel force system to create grip. The only difference is that if we're not using the constraint system, then we have to add this force at position ourselves versus letting the solver do it for us. So that's all this is doing. So if we're going to use theirs, the solver will go ahead and do this for us. Otherwise, if we don't want to use it, then we just have to add a force at position instead. And to do that, what we're going to do is we're going to take the new desired length. Again, this is the hit result distance. This is the suspension move position, right? So to do this without the solver, we're just going to say dot product simulation wheel location, get the, so again, this is the wheel location state that we've updated based on the based on our traces. And then we're going to subtract the simulation impact point. So, and then we're going to do a dot product on that against the simulation up axis. So this is the vehicle's up axis, right? So if the vehicle starts moving, we're going to be updating this. We need to know that this axis is the up axis. So this would be Z, or Z1, where X and Y is 0. And again, we've just created little structures so we can just easily, maintain that. And then after we get that product, we're just then going to add the wheel profile get effective radius. So this is a very, very, very long function. Also, we can get the suspension move position. Once we have the suspension move position, we'll be able to work with that a little bit later. So next we've got the suspension length. So this is the new desired length. So this is coming from the distance. This is to get the effective radius. So this is set suspension length. And then what we have is the suspension profile. This is the set local velocity, state, wheel, local velocity. And again, we're getting the local velocity at the index. And then we have the wheel suspension profile simulate. So this is actually going to run the simulation of the spring if we're not using the system up here. So that will then run that simulation. And then from there, we're going to get the suspension force, which is going to be our force magnitude. So we still need to, even if we're using the constraint system here, we still need to run the simulation because we still need this force magnitude, because we need this force magnitude for our wheel to know what the loading on the wheel is, because that's what we're going to then also need to know what the friction force, the amount of friction force we need that wheel to be providing when it starts turning. Just going to pop that there. Just maximize this for you guys. So that's the magnitude. Suspension force vector. So again, this is only if we're doing this. So you could technically take this piece of code and just put it inside of this because it's only ever going to be needed there, but we're just going to go calculate it. Again, up axis and the magnitude, and then the application point is just, again, getting the wheel location, suspension point, and offset, and then that does all of that for us. So again, this is if you don't want to use Unreal Engine's suspension system. So if you do, there it is. Solver takes care of all of that, and it's baked in. Otherwise, if you don't, we then just have to do a force at position based on the suspension force and the application point of where we want that force to be done. And then after that, again, the magnitude, suspension force, force magnitude. And again, we have a really long equation. So this is the load ratio, the suspension profile, get resting force. Again, this is the location of the this is the resting force, so this is what we pre-calculated, right, to determine what is the resting force, how much force, how much load is on this suspension, and so this is how much load this particular wheel is going to be pushing up based on that based on that spring. And then let's go ahead and add these two new functions to our wheel profile. So this is the set wheel preload force, and then we have the, again, mass per wheel. And this, again, because each wheel is, and then we're dividing that by the number of wheels in contact with the road. Again, if there's less, that means each wheel has to take on more load, versus if there are more wheels, then each wheel takes on less of a load of the vehicle. So let's go ahead and set those functions up real quick. All right, so let's go to solutions. Let's go back to wheel simulation setup. So again, we're in the wheel simulation setup because this is where this information is going to be needed. And I'm going to set up the set wheel load forces. Let's just add that function here. And then I'm also going to add the other function. Let's go back to, what was it? We need the set mass per wheel. And I'm just going to bring that, where is it? Set mass per wheel. So we've got another new parameter. And let's just make this a double. So there it is. Keep that consistent. All right, so that's mass per wheel. So again, this is the mass. This is how much weight we're calculating each wheel is going to have. So again, if a wheel is if we have a 8-wheeled vehicle, right, and one of the wheels is somehow over a hole and it's no longer in contact with the road, then the weight actually will be transferred to all the other wheels, and so that suspension is now going to have to do a little bit more work because we're missing now one of the wheels in that equation. And then we have the set wheel load force here, so let's go ahead and get that function in there as well. All right, so I'm just going to come over to the implementation, and I'm just going to add this here for now. Actually, I'm going to put this up here. And again, we have another variable that we need to add to the private, but we'll just show what's going on here. So what we're going to do is we're going to take that value. If it's a really, really small number, right? So say, so we've done our calculations in our suspension, and this wheel is not in contact. If this wheel's not in contact, then we're going to pass in a 0, and that 0 is going to tell us, the wheel, whether it's actually is in contact. So we're going to use this constant here, EU or Unreal Editor small number, right? And it's going to check to see if it's a small number. So we have another value to another variable that we're setting to our wheel simulation. So let's go over here again and add that to the list. All right, so that's over here. We've got, I'm just going to add it down here. So this is force into surface. So, and this, again, this is relative. So the more force we have going into the surface means the more friction we'll have on that wheel. When we calculate the wheel friction, means the, hopefully more thrust that wheel will be able to give us. Right, so if it's just touching the surface and there's not much weight on there, then that wheel should not be providing us as much force. But if that wheel is kind of sitting heavily in there, then that wheel will be providing, will be, the weight on there, the amount of weight on that wheel will be factored into the friction force that wheel will be providing to move our vehicle forward. And again, we'll get to that in the next set of videos where we get into when we'll be finishing this off with wheel friction. So, but we're adding these values in there since we can, as you can see, suspension and wheel friction, and torque and steering, they're all kind of intertwined into this simulation setup. All right, so let's go back to the suspension, and that should set that up for us. All right, so let's see. And then all we need is this get mesh. That's right. That's a function. So we created this function, which is our get mesh function. It's going to bring back the U component, and then we're just going to get the mass off that U component. And again, this is and so what you need is the number of wheels in contact, and that's why we kind of did this pre-calculation up there to get the wheels in contact. So that's the mass per wheel. That's the true mass. And the reason why I wanted this is because I actually want the actual true mass of the mesh, and not, you know, and not some calculated mesh value that may or may not be 100% accurate. So that goes in there. So here again, set wheel profile. So we're going to check to see if the wheel profile is in contact. If it's in contact, it's going to do this. If it's not in contact, it's actually going to then go ahead and set the wheel force to. Then what we're going to do is we're going to go into the suspension profile, get the trace, get the profile, get the effective radius, right? We still need to set the suspension length, but then we're going to set the mass per wheel to 0, and the load force is going to be 0, and then that will also make sure that we're still not in contact with the road. So this is actually being set in multiple places based on how we're calculating everything. All right, so that is the suspension system, I think. Yep. And we've added that there. All right, so I'm going to stop the video here, and we will pick up a part 3, in which what we'll do is we'll go ahead into the asset and start setting up the asset, and hopefully we should be able to see the suspension system keeping the vehicle above the ground. And so I'll show you how you can we'll set that up, create the blueprints, set it all up so that the vehicle's kind of sitting on the ground, and it should be then ready to accept the inputs, at least for steering, and then that will also set us up for the wheel friction. So we'll do that in the next video, and then after that we'll then bring it home with wheel friction simulation. All right. So once again, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to the channel. And if you have any comments, leave them in. Be free to leave them below, and I will see you guys in the next video. Cheers and have a great day.